Hey everyone, for today's lesson we're going to be learning about isotopes. So just to give you a very basic idea of what an isotope is it's two versions of the same element, but they have different number of neutrons and therefore a different mass. So to give you an example of what that looks like, so oxygen 16 and oxygen 18 are isotopes of one another. So the first thing you'll notice they have in common is they both have 8 protons. So 8 protons is what defines oxygen. Anything with 8 protons will always be oxygen. Where they differ, however, is that oxygen 16 has 8 neutrons, so 8 protons plus 8 neutrons will give me a mass of 16. For oxygen 18, we still have the 8 protons, but we have 10 neutrons. 8 plus 10 gives me a mass of 18. So it's the same element, but the only difference between them is number of neutrons, which gives us a different mass. So next I'm going to go through and fill out this chart, and I'll show you how you can use your given element number, given number of protons and neutrons to calculate the unknown pieces of each of these isotopes. So we're starting with hydrogen with a mass of 1. So if we look back at the table, hydrogen symbol is H, it's up in the upper left corner, and we know it has a mass of 1. So number of protons, this is what we did in the previous video, so we just look at the square. So if we just look at hydrogen's square, we can look at the atomic number, and that's going to tell me my number of protons. So right there in that upper left corner, we have a 1. So my atomic number for hydrogen is always going to be 1. So if I'm dealing with hydrogen, that number is always going to be the same. All right, so now that we know that my protons have a mass of 1, and my total mass of the atom is 1. So we can therefore assume we have 0 neutrons. So this column right here plus the neutron column is going to equal the mass column. So we know this is a 1, and we know that the answer for mass is a 1. So 1 plus 0 is going to give me 1. Now for electrons, this column is kind of irrelevant when it comes to calculating mass, but for ease sake for this video, all of our electrons are going to equal our protons. This column over here on the far right where it says neutral or ion, this just means my protons are equal to my electrons. So if we have 1 proton, we'll just assume we have 1 electron, and for the sake of this video, we'll just assume these two columns are always going to be equal. So next problem, we have beryllium. And we know that beryllium is Be with an atomic number of 4, and that's all the information we need to know in order to solve this problem. So if I want to figure out mass, all we have to do is add protons plus neutrons. So we have 4 protons, 5 neutrons. 4 plus 5 gives me 9. And because we're assuming that my protons and electrons are equal here, we're going to assume we also have 4 electrons. And again, that 4 does not get counted as the mass. The only thing that matters when we're talking about mass is our protons and our neutrons. So if this helps you out, I'll just put this right here. So 5 plus 4 equals 9. That's how you calculate mass. So this next one's a little bit backwards. So we have the mass number, but we're not given the element. But we don't need to be given that off the bat. We're given protons. So we're going to work backwards a little bit to figure out what the element is. So we know that we have 5 protons. So we can just look back at the periodic table and figure out which element has 5 protons. And that'll be right here. That would be boron. So we can go back to our chart, type boron, symbol B, and we have a mass of 11 and we have 5 protons. So 5 plus what gives me 11. That's how we're going to figure out number of neutrons. So 5 plus 6 is going to give me 11. And again, electrons are going to be equal to protons here, so that's going to be 5. All right, so I'll do number 4 as an example, and then I'll leave the rest of these for you to do as the assignment. So number 4, we have Pb with a mass of 207. Pb is a little counterintuitive, but Pb is lead. So down here, and lead has 82 protons. So we can take that and go back to our chart. Pb is lead, atomic number is 82, and that's always going to be the case with lead. Lead will always have 82 protons. And now, to figure out neutrons, we have to figure out 82 plus what is going to give me 207. So you can just take 207 minus 82, and that's going to give you 125 neutrons. And then again, electrons, so you're just going to assume this will also be 82, but that's how you figure out number of neutrons.